Hello everyone, welcome back to my channel. I am Pile of third semester, pursuing my computer science and engineering specialization in cybersecurity degree from Sri Venkateswara College of Engineering. And today's subject is mathematics for computer science. And today's topic is exploring ANOVA techniques and basic principles. So in this video, I will discuss about Introduction, Fundamentals of ANOVA, One-Way ANOVA, Assumptions of One-Way ANOVA, Two-Way ANOVA, Interpreting ANOVA Results, Post Hoc Test, Repeated Measures ANOVA, ANOVA Limitations, and Conclusion. Exploring ANOVA techniques. Today we will delve into the world of analysis of variance, that is ANOVA, a powerful statistical tool for comparing group means and understanding variation within data. Learn how to apply ANOVA to analyze research findings, draw meaningful conclusions, and make informed decisions. So first come to the fundamentals of ANOVA. So there are three fundamentals of ANOVA: comparing groups, variance analysis, and F-test. Comparing groups, that is ANOVA helps you analyze data from multiple groups to determine if there are statistically significant differences between their means. Second is variance analysis, the core principle involving partitioning the total variance in data into different components such as between group and between and within group variances. F-test. ANOVA uses the F-test to evaluate the ratio of between group variance to within group variance, providing insight into group difference. Now come to one-way ANOVA. So in terms of single factor, one-way ANOVA analyzes the effect of a single independent variable or factor on a dependent variable. For example, comparing the effectiveness of three different types of fertilizers on plant growth, the factor is fertilizer type and the dependent variable is plant growth. Assumptions. One-way ANOVA relies on assumptions about the data such as normality, homogeneity of variances, and independence. Assumptions of one-way ANOVA. So the first assumption is normality, second is homogeneity, and third is independence. Normality, that is the data for each group should be normally distributed, meaning the data points are clustered around the mean. Homogeneity, that is the variance of each group should be approximately equal, meaning the spread of data points is similar for each group. Independence, the observation within each group should be independent of each other, meaning the values for one observation should not influence the values of others. Two-way ANOVA. So it mainly depends on two factors. Two-way ANOVA analyze the effects of two independent variables on a dependent variables interactions. It explores the possibility of interactions between the two factors. That is meaning the effect of one factor depends on the level of the other factor. For example, investigating the effects of fertilizer type and watering frequency on plant growth. The factors are fertilizers and watering, and the dependent variable is plant growth. So now come to the interpreting ANOVA result. So the first one is F statistic. The F statistic indicates the ratio of between group variance and within group variance, providing a measure of the effect size. Second is p-value. The p-value is used to determine statistical significance. A low p-value, typically less than 0.05 or 95%, indicates evidence against the null hypothesis of no group differences. Third is conclusion. Based on the F statistic and p-value, you can make a conclusion about the presence or absence of significant differences between groups. Now come to post hoc test. So there are three major steps involved in post hoc test. The first one is pairwise comparison. When the overall ANOVA test reveals significant differences, post hoc test help identify which specific group differ from each other. Second is multiple comparison. Post hoc test correct for the increased chance of type 1 error, that is falsely rejecting the null hypothesis that arises from multiple comparisons. Third is popular test. Common post hoc tests include Tukey HSD and Skew test, each with its own strengths and limitations. Repeated measures ANOVA. So, within subject design, that is, repeated measure ANOVA is used when the same subject are measured multiple times, often under different conditions. For example, measuring participants' anxiety level before, during, and after a stressful presentation. The advantages of repeated measure ANOVA is it allows for a powerful analysis by controlling for individual differences, making it ideal for studying changes over time. ANOVA limitations. So there are basically three limitations of ANOVA. The first one is assumptions. ANOVA's validity depends on meeting its underlying assumptions. Violation of assumptions can lead to inaccurate results. The second is data distribution. Deviations from normality can affect the accuracy of p-values and F statistics. Third is unequal variances. That is, significant differences in variances across groups can lead to bias in the results. At last, not the least, the conclusion. First, powerful tool. ANOVA is a powerful statistical technique for analyzing differences between group means. Second, assumptions. Understanding the assumptions of ANOVA is crucial for its accurate application. Third is interpret result. Proper interpretation of ANOVA result require careful consideration of the F statistic, p-value, and post hoc test. So this was all about the ANOVA techniques and its basic principles. Thank you.